So this is basically like how you find your amino acids. So like this is module A, like halfway through, whenever we start talking about like peptide bonds, and I know like I've had multiple people be like, I don't understand what the hell's going on here. So the idea is that this is an amide, right? From our like functional groups. I mean, like you can drop it flip the other way, like on our like list of things we have to memorize. They have it the other way. The idea is like anything with a nitrogen bound to a carbonyl or whatever. Like this is a peptide bond here, and then this as a whole is called an amide group. So the idea is that this is called a peptide bond because of the fact that you have a carboxylic acid and an amine group right here, and usually it's like NH2 or something like that, that are getting combined. So what ends up happening is these combine and you end up getting this amide group plus like water, basically, because you're losing this OH group and one of these hydrogens with this creation. People are like, isn't that like having to do with like hydrolysis and all that shit? Doesn't matter. We make water with a lot of reactions. It's just that specifically this one is this not a substitution? Yeah, this would be a substitution reaction because you're substituting this nitrogen, this OH group that is being bound to that carbon. And then the idea is that you're substituting one of these hydrogens for this carbon that's being bound to the nitrogen. So the idea is like you're substituting what's bound, and in the process you're making a longer and longer chain. That's how you're forming a peptide bond. And that's what this specifically is, like this part right here. So then one of the things that we're expected to know how to do for this exam is being able to identify where our peptide bonds are and determine how many amino acids we have. We're not expected to know the amino acids because that's dumb and amino acids are stupid, but not really.
So
but
basically,
like,
you just find all your nitrogen, oxygen,
yeah.
double bond.
So I usually just say start wherever you're going to start on this chain. Doesn't really matter where. And I say draw a line through it. So this is nitrogen to the carbon with a double bond of oxygen right here. So I start right here and I start going around in my circle. Doesn't matter which way you go, I'll go this way today. And then I basically keep going, follow this along until I find another double bonded oxygen, and I look and see there's a nitrogen next to it. I don't know why I draw two lines, just one line. So the idea is that there's another line right there, goes between that bond. So then I found that, and I keep going, I keep looking, there's another one right there. Keep going, keep looking, there's another one right here. This is basically like the idea of like I tried to take like the structure from our module and put it up here, but I didn't want to draw all the extra stuff. So in terms of you keep going, keep looking, there's another one here, but people see this and they think, oh, there's a nitrogen there, so that's one, right?
But
No.
there's not a double bond oxygen.
There's not a double bonded oxygen to it. So this is not a peptide bond here. It's just included as part of that amino acid. So then keep going, find another one, mark off, keep going, find another one, mark off, keep going, and then basically like you'll have like these little substituent groups and stuff that are on there, but just going around in a circle and finding
So that
where,
one does, oh that one, oh okay, so that
finding
doesn't
where I have those points that separate.
that bottom
That's,
one, that doesn't count
that
because
doesn't
you
count.
have
That's just a
carbon.
group. That's just a group. There's just carbons there. That's just a benzene ring. I was just
Because you have
drawing
a
it
carbon between the nitrogen and oxygen.
in. Do what?
Because you have a carbon between the nitrogen
Yeah,
and
you have a
oxygen.
carbon between this nitrogen and that oxygen. Yeah, right here. So it's one of those, like, you'll see these big giant groups, like here's another one that's got a nitrogen over here. You'll see ones where, like let's say that, I'm doing black that way, it's like, kind of like, makes sense. Where you'll see, I didn't really give myself a lot of room to draw this out because I like shorthanded this. But you'll see like a bond coming off of like right here or something like that. And you'll see a double bonded oxygen or whatever. There's not going to be a nitrogen over there. or whatever, and people go, oh, the nitrogen is right here, so I cut right here, and it's, no, it has to be directly next to that carbon, or whatever. So if you see this, and you don't see a nitrogen directly next to this carbon, it's not a peptide bond.
Okay.
So then once you kind of have all your dashes or like lines drawn in or whatever, like I just say, okay, I start combining or whatever. So I just combine my circles and do that all the way around until I have all of my circles combined. And like there's like other groups you're gonna have to like draw around and do all that fun stuff. But the idea is that that's how I would draw my circles, is I would do this in order to know where my groups are or whatever, and then count from there. So then it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like I said, I stole this from the lecture, I just didn't draw all the extra stuff in, but the idea is that you should be able to count once you have your circles drawn in. But don't circle your amino acids until you do all your dashes. I feel like the fact that he did it with like circling them as he went, it confused people because they couldn't actually see what else was on the structure, because as you draw more and more circles, you get to the point where you're like, am I circling or am I doing whatever, you know, in terms of like what I'm looking at. And since like we can't draw on our like computer screens during the exam because it's in the lockdown or whatever, what I would say is I would just pick a point on here and say, okay, cool, I'm gonna pick this point. I'm gonna start from here because this is my number 1. I drew my dash or whatever, and then I draw another dash, put a tally. Go here, draw another, you know, mentally, because you can't do this on the computer. Draw another dash, do another tally. Keep going, do another dash, draw a tally, keep going, do another dash, etc., until you get back to the point where you are at the one that you started with. And it's one of those where I try to pick one that is very distinct. So like the fact that this has this on here, like very distinct, very easy to pick that out of this whole giant molecule that's on our thing. Or like with like the benzene ring, like that's a very distinct thing that you can see and go, okay, cool. Like I can start here and know that I'm not gonna get basically caught in a big circle or whatever. And he might not give us a big circular amino acid. He could very much just give us like a straight line of amino acids, you know, and say, okay, this is one thing, this is the next, or whatever. So yeah. Question?
That actually makes a lot more sense.
Yeah.
Yeah, it was harder to try to circle in one by one.
I don't like circling one by one because it's like, yeah, like I get lost in my circles, you know, especially with the big complicated ones, like, I mean, like this one, like I can't tell what the hell I'm circling.
Yeah.
You know, so yeah, it's one of those, like I draw a dash and then I circle afterwards, after I've drawn my dashes. And like, theoretically, if I was gonna like sit there and actually like draw it out, I would be super lazy. I would literally write just like NO and then just like draw a line and then like NO and basically just do that until I know like how many amino acids I've got like that way too, and then do my dashes that way if I was gonna have to actually like draw out this molecule. But he's gonna probably give us something, not exactly this, but something pretty close to this. I mean, he might give us this exact same molecule again. And the idea is that you would just have to be able to know, like, you can't really actually draw dashes on your screen, but like, you can say, okay, cool, I'm gonna start with this amine group here, and the amino acid chain that's closest to this. Because your amino acid chain will always have a nitrogen on the front and an OH on the back for each amino acid. Because once again, we're combining this amine group with this carboxylic acid group in order to make a chain. And if he draws it out as a line, like if it's like a line of amino acids, one end will have your NH2 on it, and the other end will have carboxylic acid on it. I'm gonna stop on this.